one. Hello, everyone. Welcome to tonight's class in the Cloud Solutions and tonight's Cloud Solutions and API Integrations class in the Data Engineering tract of Omaha Data Science Academy. This is winter 2024, and the class tonight is Cloud-Based Machine Learning Services. So this is where, in particular, we will investigate both software and platform as a service, those offerings for machine learning and AI, and what's available within some of these platforms as far as software, hardware, existing REST APIs, and platforms that help you build, maintain, and deploy models, machine learning models. Okay. How's this class structured? In the first hour, we do introduction, machine learning services, and APIs. That's the overview I gave there on the first slide, just introducing you to software and platform as a service, because they're both in machine learning, especially within the cloud, and APIs. So whether it's you deploying it yourself or connecting to somebody else's model, an existing API, we'll see how we can work with that. Hour two is working with Machine Learning Lab, which is Azure Data Science, or is Fabric Data Science. We'll show you where we build models, manage the life cycle of models, so the building, the maintenance, and monitoring of the model and continual updates, and then deploying a model, so deploying it via cloud platform and REST API. So hour three, we will do the practical building a basic machine learning model and deploying it using Microsoft Fabric. So class 6, machine learning and AI services, software as a service and APIs. So software as a service, I'll define it here in a minute, but it's really having software that's available to you from or provided by other companies through an interface or other REST APIs for you to use in your own applications, or whether it's creating machine learning models or getting data, or using somebody else's model. We'll see more of that. Microsoft Fabric is actually considered a software as a service versus some of the other platforms. So platform as a service, this is really like having all the tools built into one and like a managed server. So if you've ever heard of tools like Dataiku or Databricks, those are like all-inclusive, not only just the software, but it also runs servers on your machine. So it might have a database server, it might have storage and processing all integrated, and then you are configuring the hardware. And even some aspects of Microsoft Azure platform as a service. We'll also look at some of those because almost all of those will have some aspect of model management and deployment integrated into them. We'll also take a look at Azure AI and ML services. So why use the Azure why use Azure Machine Learning or in Microsoft Fabric? Why use data science? We'll go through the components, how to put together a model and deploy it, and then we will do a demo. Okay. What are machine learning and AI services? So these machine learning and artificial intelligence services encompass a range of cloud-based platforms and tools that enable individuals to organize, implement, deploy, and manage AI models. And maybe something like I talked about, platform as a service in Databricks. So Databricks is like a data science platform, collaborative platform, and it has a workspace where everybody collaborates. It has built-in Spark. has its own database and storage, and then all of these integrated deep learning and machine learning tools. So this is Databricks is available within Azure. It's integrated and also its own platform, all-inclusive platform. So with platform as a service, it's like all-inclusive. You run your own servers, compute. It's highly configurable within Azure, and it's all-inclusive with these tools. So software as a service would be more like these REST APIs within Google Cloud. You have your machine learning existing services that you're connecting to. So it's a cloud machine learning service or a vision API, image recognition or speech or natural language or translate. Whether it's platform as a service or software as a service, they're designed to streamline the processes associated with developing AI and machine learning applications, from handling and model training to deployment and monitoring. So whether it's a platform that gives you all the tools to be able to create your own models or their existing models, they're all designed to make it so it's not as difficult to build these services from end to end or integrate them into other applications, such as Google Cloud APIs. Instead of building your own Vision API, they already exist for you. Okay. So Azure's AI and ML software as a service services, they allow users to connect and to use cloud-based apps over the internet while hosting companies manage the underlying infrastructure and maintenance. So that's the definition of software as a service. As in some type of application, cloud-based application that allows you to connect to it and use the services while that company manages the underlying infrastructure and hardware. So an example of software as a service is we used it in the first homework, which is box.com. So they provide an interface to this cloud storage and management and collaborative platform for users. So you can use it through your web browser, but they also provide a bunch of services on the back end that we went through in Postman. So they have the opportunity it's pretty extensive back end or pretty extensive software as a service. They put a lot into it. Being able to do like all sorts of operations and even automatically upload files, delete and create folders, create sharing links like we did in the homework, any number of things. So they provide their platform entirely as software as a service, and they manage everything underneath themselves. So software as a service is cloud software, typically delivered through a web browser or REST APIs. There are a few other ways that they could be delivered, like programmatic APIs or the various webhooks or other real-time APIs that we learned about in the second class. But generally, most of them they're usually delivered to make it easy for the end user through like a web browser interface, or developers who want to integrate different other pieces of software or services into their own applications, or back to making them communicate with each other. So an example of this would be one that I use all the time is Grammarly. Say Grammarly takes in your input and gives you AI-powered writing recommendations, which is really helpful, and it'll even help you build content. So that's a large language model that's also a software as a service, has an interface on it, and it connects to Grammarly to be able to run those type of models. Another one's CrowdStrike, so that's real-time threat detection. So instead of having your typical antivirus, it actually has models underneath the scenes that try to detect network attacks as they happen. And then, of course, the best example, or the most famous example, or maybe the most famous example, most popular one right now is AI large language model websites, ChatGPT, and then other chatbot services. So ChatGPT actually has a web interface. You can go in, that's most commonly used on a browser or your phone. And it also has a bunch of APIs behind it that you can use, REST APIs, to integrate with your own services. There are actually some built-in tools also that you can do your own prompt engineering, which guides ChatGPT on how to answer certain questions. So there are a lot of tools that it gives you without having to build the model itself, which is really useful. And then last, Azure has software as a service. There's an AI Studio. So within AI Studio, it integrates with all of these different Azure AI services. So it's not really as much to be able to build your own services as it is like a co-pilot to test applications and then integrate it into your own applications also. We won't cover it in this class, just having everybody aware of what it is. It's really like a gateway to be able to test these different models, AI models that Azure has, and then be able to build your own applications off of it. Okay. So platforms as a service. So the platforms as a service, they encompass a variety of cloud-based platforms and tools. They facilitate the development, deployment, and management of AI models. And these are platforms that really serve as like a central hub where a team of people like data engineers, data scientists, data analysts can go and collaborate with each other and monitor all aspects of the model management lifecycle. We'll cover that in a minute. So model management lifecycle is like understanding the problem and obtaining and cleaning data, and then building the model, evaluating, deploying, and then continual update and monitoring. It's a continual process that these platforms allow you to enable you to do. So they typically include data management and prep, like I said, model development and training. Within our example that we'll see tonight, within Fabric, it's something called AutoML, which helps you automatically, or takes you through a wizard that helps you automatically generate machine learning models. You have deployment and integration of some type. So even Data IQ at the end, you validate your models and you can deploy it as a REST API as a service. And monitoring and maintenance tools. So anytime you build a model, you want to make sure it continues to make the right predictions that you expect. And then oftentimes the data changes, or maybe there's an extra column that's added, or there's some bad values that appear. Doing some type of maintenance to it's important to ensure that it runs effectively, continues to run effectively, and as expected. All right. So major platforms as a service. Amazon Web Service has a comprehensive suite of ML and AI services, including SageMaker for building, training, and deploying models. Consider SageMaker if you want to learn more. That's the platform as a service within AWS. They all have a lot of different similarities, like we learned in the first class. Within Azure, you have Azure Machine Learning, and then you have Databricks also, that are the all-inclusive platforms. In Google Cloud, you have like an AI, you have AI labs and AI models there for creating particular types of artificial intelligence models, like neural network type models, or generative large language models. And then IBM Cloud isn't used quite as much anymore, but it does have Watson Studio for building and training models and assessing and deploying. So think of these platforms as all-inclusive tools. It seems like Microsoft Fabric would be platform as a service, but it's actually, you consider it a software as a service because the Fabric portal is like your interface to all of these different services, and then they're enabling you to connect to the services. Platform as a service is like a piece of software, whole platform that you can configure, such as SageMaker, and then it has all the tools built into the platform. I know it seems kind of the difference is very light, but there is a difference between the two. I'd say the biggest difference is all inclusive with the platform as a service and the ability to configure versus kind of tying it all together through an interface and a number of services. If you think of Fabric, it's a bunch of different modules like OneLake or your cloud databases or Data Factory, and they're all accessible through an interface and integrated together without being all part of the same piece of software. Okay. So jumping in now that we've covered the different types of cloud-based machine learning services and platforms. So what is Fabric data science? So you'd say, why Azure machine learning or Fabric data science? Azure machine learning is part of Azure. It's like the bigger platform. Inside of it, we have Fabric data science that's meant for collaboration. A few less features than Microsoft Azure, but Azure machine learning, but still the same capabilities. So it is a cloud-based service that enables data scientists to build, train, collaborate, deploy, and manage machine learning models efficiently. So I consider Azure machine learning as the platform as a service, and then we use Fabric data science as the software as a service with many of the same features. So key components of Fabric data science is automated machine learning. We'll take a look at AutoML, being able to automatically generate and pick the right machine learning models based on your data. And ML flow is code that helps you manage and organize models that you build within Microsoft Fabric. And we'll also see an example of that. You also have Python and Spark notebooks. That's how you will build your models within Microsoft Fabric data science with some help from AutoML. Within Fabric data science, you have scalability and flexibility, typical key components of the cloud. You have the ability to deploy models, whether it's to a database, storing those results, or doing it by REST API. You have the or microservice, you have the ability to do both. And then continuous monitoring and management, whether it's by Power BI or other fit statistics of the model, other statistics related to the model that you built. You're able to continually monitor and manage it. And it has lots of benefits for businesses and teams. So being collaborative environment, being relatively easy for teams to use, accelerates model development and deployment. It's cost effective and scalable, which is a good property of the cloud. Increases productivity and collaboration. Even as a software as a service platform, it's still all brought together in one spot where people can work together as a team, especially with concepts like workspaces. And then enhances decision making with actionable insights. Makes it easy to create these models and deploy them. Okay. So Fabric Auto ML. So we talked about that as being one of the biggest key components. Fabric Auto ML is an automated machine learning capability that helps create optimal models. And I'd say optimal models based on the data that you give it and some options that you select. So the features are feature engineering. So it does some of that for you. It creates variables that are predictive based on your model, or based on your model and your data. Instead of having to explore and do some of that work for you, it tries to come up with its own set of variables that will predict whatever you're trying to predict. So like with coin, we'll see an example tonight of the price history for the Ethereum cryptocurrency. It will try to predict those prices based on variables that it creates from the data. So that's really valuable in getting like predictive power out of machine learning models. Hyperparameter tuning is similar. All the little things around the model, being able to do that and adjust those automatically. It evaluates the model and validates the accuracy of the model. Tells you how important each one of those features it creates is. So some things will be more predictive than others. And then model explanations along with it. So you have the interpretability to go with it, so you know how it's making its predictions. So the process, I outlined the process of using AutoML, and it's really like a start to finish process. So you're able to do pre-processing with AutoML, feature selection that we talked about, selecting your variables, testing various machine learning algorithms on it. So in machine learning, you have things like, you have your typical statistical type things like regression, but with machine learning, you have all sorts of optimization algorithms that go around it. It helps you with those, selecting the best, and then you can do model training, evaluate the performance, so how well it's making predictions, selecting the best model, and explaining the results. So there's a 8-step process here of going from start to finish, like beginning to end to end with AutoML. So first you create an AutoML experiment. Second, you select data source from a lakehouse or an external table. Third, you would select a problem type. So this would be like a model type. You can do classifications, regressions, time series, or like a computer vision, which would be like if you gave it a cat picture, it would try to guess what type of animal it is, or what type of thing is in that picture. So we'll do a regression model tonight. You can configure training settings, processing automated model training, or AutoML processing of the training and optimization, some of those things we talked about. You can review the results, deploy the model. We'll work on deploying a real-time model tonight. So a real-time model, anytime it'll deploy as a REST API. Anytime you send it some data, it will try to give you a single response back. So for example, if you send it new data about a point in time for Ethereum, maybe it's like the current price and some of the other information, it would try to predict the price maybe 20 days out. So, and then being able to monitor performance, track metrics, and maintain model health is a part of it. And we will walk through AutoML as our guided example tonight. So I'm going to cover this slide and then let everyone watch a video here to end the first hour. So that will take us through an introduction to all these services and then Microsoft Fabric. So ML Fabric or ML Flow kind of complements AutoML. So ML Flow in Microsoft Fabric is an integrated service for managing the machine learning life cycle. So when we talk about machine learning life cycle, it's all of these things. So data, business goal and data, framing the problem, data processing, developing the model, deploying it, and then monitoring it. Say it's a library, you'll see we'll create notebooks from AutoML, and ML Flow will be code that's inside of it to help monitor the different aspects of this. So it'll do things like tracking experiments. So experiments are like running new models or hypotheses on machine learning models. It's just like your initial guesses or your initial training of the data or your different series of different training steps of the model. So you can track these, you can track model metrics and record code visions and compare runs. So sometimes the data will change or the model gets updated and have a new variable in it or something. You can run each one of these as like a new experiment, then be able to compare your different runs and your data profiles and your models. Oh, model registry. So anytime you are want to save a model, you add it to a model registry in ML Flow. It's like version control for models, and you can do a development, staging, production version of the models. So that's like in bigger companies, instead of creating a model and having it in a system right away, you have an environment where you're developing it, you're staging it and testing it to make sure that it's ready to go into a system or some process. And then production would be people within the business are actually using it. So valuable in especially the way bigger businesses have control and changement processes with models. You can also do model lineage, so how it's changed over time, and then deployment and management. And then model deployment. So API endpoint creation, you serve this model out to users, performance monitoring, and version management. We'll see that this actually you'll create some of those statistics and then like a scored data set, I drew a blank on the name within OneLake. It is the within those tables, it'll create its own scored data set with results that you can visualize in Power BI. And then the benefits: centralized model management, automated tracking, simplified deployment, built-in versioning, and you can compare experiments. Okay. So maybe we'll have luck at playing this from my home location, this video. So she's going to go end-to-end data science scenario in Microsoft Fabric. So this is from getting started to running AutoML. I don't think she deploys it at the end, but she does export the results to the data lake, the model results to the data lake. So I'll go ahead and try to play it. Maybe I can't out of presentation mode. Seems like maybe I don't have the link here. Okay. Let me I'll find this here for everyone. Oh, there we go. The link must just not have been embedded within the PowerPoint. Let me know if you can hear this. I don't hear it, so I don't know if anybody else can.
No, I can't hear it.
Yeah, so she ends up going, I'll give this a link for everyone to take a break, take like a 15-minute break. But she goes through the data science process like we just did, being able to do data discovery. There is some data wrangling that you can do within AutoML. And then you can deploy it for batch predictions or single predictions and then generate your insight. And then she'll give you a little walkthrough using a vision example. Can personalize the runs a little bit and see all the fit statistics in the experiment. You can see the different versions. Pretty good results. You can apply the model, and I don't think she deploys it here at the end, but she stores them all in there and then visualizes them in Power BI. She does everything except deploying it, and in a way, this is potentially like deploying a model if you have the results and you show the predictions in Power BI. But we'll also see how we can deploy it as the results as a REST API, so you can use it programmatically too. Okay, I'll give everyone this link. Drop that into Slack. Really good introductory video. I like to keep these to about 8 minutes, like little demos. Okay, I dropped it in there. Please watch and finish up any quiz questions that may be remaining. Let me see how many, if we have almost everybody's responses. Yep, we have 4 responses, so that might just be just about everyone's. See, Evans, let's see. Skylar, I think we have almost everyone's except Rosendo. So I'll give everyone, we'll come back at 7:20 after watching the videos. And if we still don't have everyone's quiz responses, we'll just wait till the 3rd hour till the end of class. Okay, give everyone a break. And then in the next hour, we start to dive deeper into the data science module within Microsoft Fabric and how it works and how you can create your own models. So be back in 15.
Sounds like a plan.
Good. Exciting part coming up. Okay. See you in a few. Arizendo, I dropped a lot into the channel. I'll just share it directly with you. Quiz link. Okay. Here you go, Rosendo. So over classes 4 and 5, the last two before this class. You're welcome. Oops. Should drop those results off of there. I'll move that to the other screen. Be back in 1 minute myself. Why did I blank? Parquet file. That's what I was thinking of. Just drew a blank. Yep, presenter we got him. Perfect. You completed that pretty fast. I'll still give everyone a few minutes since I said 7:20. All right, we will cover the quiz when everyone is back. All right, everyone, once you're back, give me a sign or a thumbs up. Any type of sign, well, almost any type of sign will do. Should be careful when I say that. Start camera.
I'm back.
Skylar's back. Glad that people are coming back. That's good.
I'm here too.
Glad that Melinda's back. So just for the class, thinking it over, I think I will lecture on real-time intelligence. It's gonna try to make it as short as possible with some of the features and a quick demo for Wednesday's class, but I want to spend as much time as we can working. I may in the future, I might integrate it into the class. We have eight full lectures, and I'll include 1 or 2 questions on the final. So the only thing that'll be new on the final that you haven't seen in quizzes will be over the lecture tonight, and then I'll have 1 or 2 questions over maybe just 1 question over real-time intelligence. It's worth covering, especially for like monitoring data for like data management and model management, being able to generate alerts and thresholds and things like that. I've seen it where you go crazy over alerts. So you generate like 1,000 of them and then nobody pays attention. Hopefully, though, they're meaningful alerts or there's not a bajillion of them. I haven't used it yet, so I'd dig in and see what we can do with it. But I'll make it short. Okay. 7:22, I'm assuming everyone else is back. So go ahead and share the results of the quiz. Everyone did a nice job on it. Share the screen. Okay. So yeah, everyone did a nice job. There's one question that threw everyone off. I'll cover that. So I think everyone, or close to everyone, got this. So what's true about fabric data engineering and synapse analytics? So is all of these. So synapse analytics and fabric data engineering is kind of like the all-inclusive platform that has Spark and SQL Server, Power BI, ability like notebooks for collaboration. Data scientists can build models in notebooks, integrated with Azure Gen 2 and OneLake storage, lots of different integrations out of it. The only one that it didn't put there, and everybody caught on to that, is does not provide on-demand querying. So I did the negative version, but everybody caught on to that. Okay. So why are APIs crucial in data science workflows? It can be all of the above if you're doing real-time analytics. We'll see in this next hour. Sometimes it's useful in deploying and managing the models that you build. Automating data streams, putting those in pipelines like Data Factory, so you don't always have to go out and manually get data or get it in some unclean or different ways. It's always a consistent way along with that. So it's all of the above. Okay, main benefits: automating data collection. So everybody got this too. So retrieving data, automation, data quality, scalability, and flexibility. Okay. So in your own words, what are the steps to copy REST API data to Fabric Warehouse? So all these answers were good. I like this last one in particular. It's very descriptive with each one of the steps. So first, determine the API endpoint and gather authentication credentials. Yep. So looking over the APIs, reading the documentation, going in and getting your authorization tokens is first. Then making sure there's a linked service for the REST API and Fabric and test the connection. So you go in there into the pipeline, you set up your credentials and you test it to see if it works. And then you create a data warehouse item after that as your target. And then you can copy data, map the data, and then create the new table as your source, basically. And then monitor the status of the process. So very nice answer there. Exactly. I do it from start to finish. So what's Apache Spark use case? So really big data sets using distributed clustering. So what are the use cases behind cloud-based data processing? So you can do all these different things in the cloud. We covered them in the class: data warehousing and analytics, creating your own machine learning and artificial intelligence models, doing real-time data, log processing, genomic data analytics, analysis, analyzing big sets of data, and all sorts of different things. Okay. So what is a use case for real-time intelligence Azure Stream Analytics? So I blame myself. I mentioned watching YouTube videos, and you technically could through a real-time API. Internet of Things data, like sensor data, where there's a whole bunch of coming in. That's a perfect use case for real time. It's coming in near real time, and there are like millions of data points. Think about like a self-driving car trying to identify everything on the road. That's the type of data that would be coming in. And like you can use Azure Stream Analytics for watching YouTube. I give a point there for my misleading. They're talking about streaming YouTube and real-time APIs. It's also true. Okay. So through a DP 600 question in there, the certification exam, just going through it, it's like a lot of hypotheticals. They want to know like what you would do in certain situations. So like what tools would you use in the Microsoft Fabric environment to be able to accomplish like whatever scenario they give you, which is what I kind of try to do on the final too. But this one was out of it. So you need to process data in a lakehouse using Python. Which option should you choose? So Notebook's perfect for that. So yeah, the data flows are not Python related. A pipeline, you could put code in a pipeline, and not so much in a SQL endpoint for Python, but that's specifically what the notebooks are for. Then in your own words, what is Azure Data Factory? We'll go with a simple explanation here. Azure Data Factory is cloud-based ETL and data integration service that automates data transformations across various sources and destinations. I think that's like pretty well stated. It also, don't forget that it also is kind of like an integration tool. So it also extracts data. It does like the heavy lifting, and then it can do transformations and loads into whatever source, or just ELT even extracts and loads, and then you can define the transformations later out of the data lake. So that part of it, also the data extraction and loading into data lakes or other systems, and then transferability to do transformations in between is a big part. So multiple choice, what are the different components of Azure Data Factory? Oh, everyone nailed most of these. There's also the mapping component of the data pipeline. So if you think about the copy utility, being able to do source to target mapping, which is a big thing when you're doing ETL, mapping the columns from the source into whatever target that you're doing, whether that's a database table or a Parquet file or a Delta table in the Delta Lake, whatever it might be. It's defining what variable goes to what variable and what data type goes to what data type from source to destination. Right. So there's 3 activities and their purpose. So there's data flow activity for transformations, lookup activity, drives conditional logic, and then your copy activity is another good one, copying data from source to destination. There's a fairly decent sized list, or even like Azure Databricks activities that you can do within pipeline. Any number of them. Those are everybody got the main ones, even including a Jupyter notebook into like one of your activities or steps, adding a notebook into your steps. Okay. What method provides the best performance for loading large amounts of data into the data lake? So the correct one would be Spark Notebook. So that's like, well, actually, so this is the one that tripped everyone up. So I have the Azure Factory copy data activity. So I should have probably put, this is like a generic version of the question for like a bulk loading of data into the data warehouse. That's where Azure Data Factory is really good at lifting a lot of data. Although Spark Notebook, you could also do that distributive. You can distribute it too, right? So saying like the best method for loading large data into it. It depends on how large the data is, I guess, and what you're doing. But Spark Notebook's not necessarily a wrong answer for processing. Using Spark isn't necessarily a wrong answer for that either, depending on like what type of large data set you have, or if it's real time and or streaming or so forth. Okay. And then I realized number 11 was just a duplicate of the one up here. Question number 4. So nice job, everyone, on that. I think you have pretty good handle of the main parts of the platform, the Fabric platform, all the way from storing data to processing data in pipelines, and then using Synapse Analytics for API integrations and the purpose of it. Okay. And then on the final, like I said, it will include tonight's lecture. I'll do a very short lecture on the real-time intelligence module on Wednesday, and then we'll use the rest of the time for working session and to hand out the final. All right. Let's go ahead, continue with lecture. Okay. I was thinking during the break, there's a point that I wanted to make here. I forgot. It felt like a good point. Oh yeah, all of this is, so my theory is to, in general, use like a SaaS service that already exists instead of building your own models. So what we'll talk about with Fabric ML and then Spark ML, and then using Fabric Data Science. It's really when you're building your own models for proprietary purposes, specific purposes. There might be good reasons for that. You may be building it large language model on your own wiki and need to be able to do certain things, specific things, and you don't want to feed the data to something like OpenAI. A lot of it would probably have to do with privacy. I think is that you want to, in situations where you don't want to send your data to the cloud, and you end up building your own machine learning models. Of course, I'm going to find out what the insurance companies is that with what's the name of that insurance company where the CEO was just shot? I draw blanks on names all the time. United Healthcare. So they actually have machine learning models, internal machine learning models built to evaluate claims and help them predict whether they should deny or accept a claim. I think probably really the intent is I'm sure they still review them by hand, but use it as their own aid. And they probably embedded some of their own logic into it. It's their own proprietary model that they've created instead of using a existing claims model. Although they potentially could do it too. Probably usually when you create it, it'd be for a specific reason or purpose, or it's proprietary, or it's data that you don't want to put in the cloud. But there's still good reasons to build your own models and deploy your own models, which is what we'll talk about the rest of this class. All right. Well, so we will go ahead and we're doing all of this from the perspective of the data engineer. So in general, the data scientist will probably do these first two parts, the business goal and the framing. Maybe they do some initial data processing and model development, and then you're taking the code and then you're refining it as a data engineer, and then you're deploying it and helping with the monitoring. I would say most likely you're helping the data, you're enabling the data scientists modeling to make it more stable and robust, and putting it in a production environment and then distributing out the data the way that you intend to distribute it. So it's really like a back and forth, say really collaborative effort. And of course, with data engineer, it helps to know some about model deployment and then the type of models and data that's being used and built. So two-way street. Okay, we'll continue with the lecture. Go ahead and it looks like I'm sharing my screen. Everybody can see the using Spark ML and Microsoft Fabric. I think everybody can see it. Let me know if you can't. So as you saw in the video, when you use AutoML in Microsoft Fabric, it generates a notebook for you. And that notebook will you have two options. You can generate Python code and use it with scikit-learn, which is your traditional Python library for smaller data sets. And it has a ton of machine learning libraries in it. Or you can generate it using Spark ML. So Spark ML is really similar to scikit-learn in the sense that it has packages for data ingestion, cleaning, model training, testing and validation and deployment. And it has its own pipeline methods within the library. And so does scikit-learn. However, with Spark ML, you get that distributed computing or processing of big data sets. So where Spark ML doesn't have quite as much of the machine learning modeling as scikit-learn does, that Spark ML has some of those methods, but primarily for those large data sets. And is everyone familiar? Did you cover scikit-learn in your in your machine learning classes?
Yeah, we did.
Okay. Just making sure for those who aren't familiar, I'll drop you a link here, but it's pretty much like the premier library for building machine learning models in Python. So scikit-learn library. It is integrated with pandas. You can do operations with NumPy and plot with like matplotlib library. And it has all these different types of machine learning models: classification, regression, clustering. Helps with model selection that we talked about, and then like all this pre-processing stuff. So definitely a good place if you have a smaller data set or test data set. It's like the premier library within Python for it, but not really meant for processing like truly big data, like millions of data sets or real-time data, just on smaller data sets that you can load into the memory of your computer. So just for anybody who hasn't seen scikit-learn, I'll drop that link into Slack, and then we'll continue. That's explaining the difference. You can have two different types of code that's generated out of AutoML, and you can also do Spark. So Spark ML can also be integrated in the machine learning workspace. Can leverage Fabric's cloud infrastructure to scale your machine learning workloads. So key features and benefits, obviously, a scalability of the cloud and the technology itself, being able to parallel process. You can break it into a bunch of small workloads and run your model on them, and then produce the results with, and then you could allocate cloud resources to them like you couldn't with a single server or computer that you're running your you're running scikit-learn on. So benefits of using it in Fabric: you also get an end-to-end machine learning workflow. It's fully integrated. You have all these different steps from the very beginning of the machine learning lifecycle to the end. Scalability, I already talked about that. And then ease of use. So Microsoft Fabric, using Apache Spark and setting up a server and doing it is kind of hard in its own right. So in Microsoft Fabric, they make it relatively easy for data scientists and engineers to use, manage, and deploy machine learning models. There is a lot before these type of platforms. There's a ton of technical expertise that's needed to set up and configure a Spark ML server, and then to be able to get the code and environments right, and then create and deploy these models. These type of platforms are making it much easier not to just build them, but also maintain and manage these type of models and be able to process data on a large scale that machine learning models often need. Okay. So comparing the key differences between scikit-learn and Spark ML, the scale is one, talked about. Scikit-learn is really good on small to medium data sets, where Spark ML is optimized for big data sets and distributed computing. You may even start with a subset of the data, of the big data set, and work with it in scikit-learn to see what the best machine learning algorithms might be. Easy to use. If you know Python and you have familiarity with pandas and some of the libraries, there are tons of code examples out there model building. So relatively easy to use, where Spark's a little more complex. Have to have a Spark cluster set up, but Fabric makes that fairly easy. Algorithm support, so wide range for scikit-learn. Limited with Spark, but the purpose is more about scalability, data processing. They're both in data frames, but Spark has its own specific data frames for distributed processing. Deployment, single machine on scikit-learn, Spark ML can be deployed on Spark clusters or within a platform like Azure. So scikit-learn's best for research or smaller data sets, Spark ML for large ones, close to real time, and then community, so large established community with scikit-learn. Spark is open source, so it has fairly large community too. But now lots of resources out there you can go to, generative AI to ask it questions or create code. So last, Fabric. Oops. So here's the process within Fabric to deploy, monitor, and update machine learning model. So we're going to go through these steps with our guided example. So model deployment steps. So after you build a model and put the model in a registry, you can see it in your workspace and hit the deploy button. And if you choose a real-time endpoint, you can then configure it and set up authentication and test endpoint functionality. So with monitoring steps, oftentimes I would do this in Power BI, but you can also configure these monitoring events. You can set up alerts for thresholds, can enable data drift detection. So that's if your data profile or changes or new values are added or new columns appear in the data set, you can detect some of those. And then configure logging settings, so you can log any calls to the API, or you can log predictions and so forth. And then model updating steps. So when you train a new version of model, you can log that to MLflow. MLflow is like the management tool for machine learning models in Fabric. You register a new version. You test the performance of the new model. You can stage promotion in here that we talked about, like development, staging, and production. You can do those through all three stages to make sure that it's the predictions are good and that's ready to use. And then you update the endpoint with your new model, and then you verify your deployment. So going from deployment, monitoring your model, and then ultimately every so often you're going to go in and update the model with new data, or if you see the performance of the model isn't very good or you're alerted to something, maybe you update the model, train a new version of the model, and then you redeploy. So it's really like a continuous improvement. Once you create a model, it's not necessarily done for good, especially as it receives new data and makes new predictions. The key is to continually improve and adjust to be able to make the best predictions. And we'll work on those tonight. Okay. So creating a REST API service. So I wanted to go through the process also. So if you were to do all of this just programmatically, if you didn't use any cloud platforms, like what does that process look like to take a machine learning model and deploy that to a REST API service? So I do some of this through code and these steps, and I'll walk you through this. So You first would create your model. And you say you create it in scikit-learn. And then there's a library you can package it into. It's called Pickle. And you could package your machine learning model into that and then load it into this code. So one of the big libraries for deploying REST APIs within Python is this library called Flask, because it has all sorts of different type of web operations like requests and get. It's like its little own web programming library. So what you do here is you load your ML model. You're starting to create the API code. So you're loading your web model. You're going to create your endpoint with this decorator, and then your predictions. So these decorators are starting to be each one of these endpoints. And then you say, is the status of the API healthy or not? You can return that. So this is like the code that sets up the endpoints and then what information it returns. And JSONify would be creating those as JSON responses. Two, you set up all the requirements, what libraries you need, because you're going to eventually put this in like a container such as Docker or some type of other platform. So it'd be related to the whatever platform you're using. Docker's a really popular one for creating Python images, repeatable images, and having it in its own environment. So you create what requirements.test for the libraries that you need in its own environment. You create the Docker file if you're using Docker. Perhaps if you're using a different platform, you may need a different configuration file for it, but we'll just talk about deploying it in a Docker container. So you have development testing. So once you've deployed it locally, you can test to see if it works. And then you have a few production deployment steps. So after you've tested it locally, you can build an image. Since the REST API is web, you need to have a web server to be able to get and push requests, be able to send responses. That's it. To receive, get responses, or any one of those operations, and then be able to send the response. So that's all done by web server. Then there's usually a lot of configuration you have to do. So web server, it's usually a certain type of web server that makes it easy to deploy REST API services. Then you have to do domain configuration. Maybe you have to do some you would do SSL for encryption. And then deploy it to a local server, or maybe even better, cloud. So if you choose the route of doing it yourself, that's why cloud platforms are such an advantage, is that it makes it a lot easier for you. There's web servers that are already managed, or Docker containers that you can go to. In Azure, they have what's called DevOps, which is a code platform to be able to deploy this in web services. It also has Azure Functions, so you can put Python code in there and run Python code. You can, and then make REST API deployment easy. So the cloud platforms really simplify the programming and configuration and setup of a web server and the libraries that are needed to be able to actually create a REST API out of your service. So deploying it to a cloud, this may be a really good option because it may already have these environments set up for you, especially environments that are like AWS, Google Cloud, or Azure Fabric already have those environments set up for you. Seventh step is monitoring the setup. So configuring monitoring metrics, monitor performance, and then additional security. So if you're setting up your own web servers, you have to take into account firewalls and security. And honestly, if you are deploying within an enterprise environment and they say they want to deploy your model as a service, I would honestly let IT probably handle a lot of the server management and maintenance and security around it. Have them manage the server themselves, and then you would upload your model results or your predictions to a database table. You run this code behind the scenes, and then you work with your IT teams to be able to develop a service that makes these predictions behind the scenes with your code. Because at a big enterprise, there's just going to be a ton of software and security and configuration considerations, having worked at big companies myself. So if you can, I'd highly recommend using a cloud platform for deployment, especially if your organization sponsors it and says it's good, and you don't have to go through all the configuration and setup and discussion and so forth. You can just deploy your models to a database table or by REST API, and you're good to go. So this is like a little how this works. So say you build a model in library like TensorFlow, you go to API. So your Flask would define your API endpoints and calls. And then you'd run a web server, and then through maybe a web interface, maybe you interact with that web server. In buttons, you press a button. Say you want to predict something with your machine learning model, you press a button on a web page, it sends it to the web server, returns a response out to the web page or application or whatever else it may be. So these are mostly, you'd usually deploy a REST API service if there's some like interaction between systems, like heavy interaction or passing data back and forth. Otherwise, a lot of times, I think a database table would suffice, or if you're only running the model like once a day, a database table would probably be just perfect to store the data. But if you're doing things like continuously using the model inside a day to make predictions, maybe you have built an internal fraud detection model or something like that, that's probably when you would deploy it to a microservice or REST API service. So to be able to use it in between systems, better integration in between systems and closer to real time. I covered a lot of technical today, but just to give an overview, we learned about the types of different platforms, software as a service and APIs versus platform as a service. We learned about Microsoft Data Fabric, Spark Machine Learning, and Azure Machine Learning. Learned about, but I didn't learn about machine learning components and workflow, but we did cover data science, Fabric data science from end to end, using Spark machine learning and deployment and what it looks like to create your own REST API service from model. Feels like is a lot of technical information. Anybody have questions over the lecture? Questions or thoughts?
Nothing here.
Okay.
I'll just
Hopefully I
be.
didn't overwhelm. That's why.
Yeah, I'll be interested to see. I keep the thing that always holds me back is the deployment because I don't know much about any sort of deployment. Just that's not my background. I'm a data analyst is my background. So
Yeah.
I think I'll have to at some point learn Docker or something similar. Docker seems to come up a lot when I'm doing research and looking at things. So
Yeah. Yeah. No, anytime you put something in production that's making predictions that people are using, that's concerning, right? Like you want to make sure that's right and not making a ton of mistakes. It's something to be careful about for sure. That's why oftentimes if you do it like once a day, predictions that are once a day probably doesn't need to go out to service, could probably be like a Power BI dashboard or a database table, and a system picks it up and gives that information. Plus, it's probably a little bit safer in the sense that you can check those results every day to make sure like your models are still producing it, that it looks right. If you're doing it in real time, that's almost where you have to have like that real time monitoring or those alerts, be able to look at that data and the prediction they made. I feel like there's a lot that always makes me nervous putting something in production that's like that. Almost all the models I've created over my career, they were just like overnight or ran once or twice a day during the day. I was trying to think of, I've never had to produce one, but now with, if you're doing like a web startup company and producing these predictive models, that might be a good use case for it too. A model that you want to share with a lot of people. But anyway, going astray. We'll go ahead and go to the demo. I did have one hang up here on the demo, but this will give you a pretty good idea here. There's also a link in here using Python and Flask on Azure Cloud, how you would implement it there. They do oftentimes recommend if you have complicated code in Fabric that you go move it to something like Azure DevOps or Azure Web Apps or Azure Functions. That's a little outside of the scope of what we're doing here, but we'll at least do simple deployments here. Fabric gives us the capabilities to do simple deployments. Okay. Yeah. So deploying a model is like huge, really. Okay. So the class exercise, I'll walk you through it. You don't have to worry too much about this right here. I need to update these instructions. But the idea of this class exercise is that we're going to start by an AutoML in Fabric. We're going to create a new experiment. We're going to select data source and choose your model and target column and configure it. And after that, I didn't get done pasting all these. Let me bring up the rest of this process and find it in my tabs. Oh man, so many tabs open. Here. Here's our process. It'll load here in a second. Use this software called Mermaid Chart. Works well with Claude to be able to create these type of visual workflows instead of just reading all the instructions. So here's what we'll do. Okay. I can drag up. So that's the first step. We'll do AutoML, create a new experiment. Experiment is like a new test or almost like a new model, trying to figure out what the best model will be to fit the data. We'll configure some of the data by selecting data source, target column, and some of the features. So features are like the variables that are going to be used to predict whatever you're trying to predict. So in this case, we'll try to predict like the current Ethereum price. And then there's a model set up. So you'll select the type of model. You'll set some of the training settings for the different types of models. In this one, we'll do a regression model on the coin history data set. And then there's the AutoML processing. So there's data processing, feature engineering, algorithm selection, and model training. This all is produced in a notebook, and we'll see that notebook in action. Then you can evaluate the model. It'll give you some fit statistics, or after you create the model, you can go into some of the model settings and be able to see those. Once the model is published in your workspace, you can deploy it. And then you could set monitoring metrics or visualize it in Power BI. I always like to visualize models in Power BI to make sure just to physically or like be able to bring it down to earth. Like you can tell quite a bit from some of the fit statistics too, but to be able to like really see it in action through performance. And then, there's maintenance. So retraining and optimization just takes you, it would actually take you probably not to selecting a new model. It would probably take you right up here to getting the new data. Like you would get new data you get updated data out of a REST API. Maybe you get new crypto data or the most up-to-date data. And then you could keep updating and deploying the model and make predictions. So this actually, Fabric deploys it in two ways. So you can do a real-time endpoint or batch inference. So both of these are REST APIs. So you could send it one observation or a set of observations, make predictions, and return the results. It also, I noted the code also produces a Parquet file and creates a table in the OneLake, a Delta table that stores some of your predictions and results too. So we are going to see this in action from start to finish. I'm going to go ahead and copy and paste this diagram for everyone so you can follow along. I have this. Actually, I'll drop the image file for it. If I can find this file. Step back. The other steps before this, and obviously this is like the last part of it, but from start to finish, it'd be obtaining data and putting it in a data lake, processing the data using using Data Factory, and maybe you store the data in a data warehouse or a Delta table or however you store it. And then you feed that data in to the start of your machine learning model. You deploy it and you create a dashboard or a REST API. You integrate it with some other system. Would be your ending point. And that image, I do have the image here for everyone to follow along. It's a PNG file, a long one. So it may take up, you may have to scroll as you go through it, but where did data science? Just renaming it for everyone. And it's now shared within Slack so everyone can follow along. Well, it's uploading. It'll take just a second. So as you're going through it, I've also found this helpful when you're using AutoML to not get, so that you don't get lost in what steps are next as you go through it. But you'll see it as part of this demo too. Okay. I did run into one stumbling block, so we'll try to get through that. So the first step in the process is to start AutoML. So just a little bit of bookkeeping items is it going through this, going through the data science module. It seems to like when you store these files the most in a Delta table. So the Delta tables are the tables inside of OneLake. So we'll go to my lake house. And I'm sure you could write code in your notebook to get the file from a different location, but just working with AutoML, we'll load this from a Delta table. So inside of here, if you go to the Lakehouse SQL Analytics endpoint, Fabric's loading for me. Remember that the Lakehouse Delta tables are these tables that we created from the CSV files. And I also created one other table. I called it ML coin overall history. So this is a table that I end up using. With Fabric Data Science, and I'll show you how I created this table. So if you remember, we started in the last class to load the overall history data into the data warehouse. I end up doing the same with fat coin history, and fat coin history is these variables, and we'll see it here in a second. So the fat coin history looks like this: date, the rate is the price, total Ethereum volume, market cap, total market cap, amount of liquidity, and then the symbols and the name. So we're looking at the Ethereum coin. There are 100 observations. one of the things that you'll want to do in the project is when you're running this model is to use the REST API to go out and get more observations. But for now, the second class or the third class we had, we loaded these CSVs into these tables. And I'll show you how I created this table. So what I did is that we started to load the other ones, the fact overall history, into the data warehouse. What we want is the fact coin history there too. And let's see, so I did that by copy pipeline. I'll go ahead. Go to my data engineering workspace. We created this one. I created one that says data factory, first and last name. And then I give it something descriptive like coin history is the name of the text file or data set that we're using. And then where it's like source and destination, source and target. So the source is coin history, target's data warehouse. We do ODSA. Okay. So I do a one-time load. I do the source as the lake house in that delta table we created from fact coin history. That's the table we just saw. You can preview the data just to make sure. Take a second usually. Took a second to query the data, so take a few more extra seconds. You could also go from a file, but we already have it in a delta table. So same data, date, rate, volume cap, so forth. The destination, we want it out to the data warehouse that we created. I created a WH ODSA test. ODSA, so first name, last name, ODSA. We created that in the last class, I believe, when we were taking a look at Synapse Synapse Analytics or the data warehousing portion of Fabric. So I created that warehouse. It's a new load, so I auto create the table, and then I give the table a name. I give it the schema name, which is crypto. So it's intended to be like a relational OLAP, online analytical processing data model. So I give it its own descriptive schema, and then the fact table I'm loading into it. So we have our source, the delta table in the data lake. The destination is the warehouse. If you import the schemas, then it does the source to destination, source to target mapping. Then you have your settings. So I did that. It ran successfully when you do add trigger, where you can invoke pipeline. And you could run it. Mine ran successfully and created that table for the first time just to verify. You can go into your data warehouse. Take a second to load. After any process runs, I always just like to go and verify the results. Just go see if it's what it's expected. And after a while, you can create an alert or a script for it. But let's go to the warehouse. So it created this schema crypto with the fat coin history table. So what I like to do also when I'm creating a model is I create a view that cleans up, that brings together all the data that I need. So oftentimes there'll be a join or I'm cleaning up some data. So like in this case, I'm converting this Unix timestamp. Right here, you see that's a date, but it's like a date time, but it's not in like any type of format that makes sense to you or I. So what you can do is, and usually I do all this in a view is either to aggregate the data and join it or clean it up for what I need to be able to run that model. So think of this as like the data pre-processing that you need to do. I'll often do that in SQL and create the view that I need. It crashed on me there for a minute. We'll try to reload. Just showing everyone that date that I needed to convert. So anytime you're creating a model, you have a process that cleans and transforms the data. Now you could also put all this in a pipeline. There are any number of ways that you can do it. You could do like a data flow and transform it and then put it in the table. Or you can drop a SQL notebook into the process. Also, different activities. You could do a notebook activity. You could create a stored procedure in a database. That's also fairly common, especially if you need to load and update data. You can create scripts, so forth. But for this one, when the data's there, I create a view. So there are always a number of ways to engineer things, different ways. Whatever the engineer's decision on whatever they believe is the best route to doing it, most effective route to doing it. I'm having a hard time loading this thing. And go back to data warehouse. Oop. Come on. I say my home setup's better. It's taking forever to load. Pretty sure that it is. I did hear my girls come home, so they're probably streaming at the same time. Oh man, come on. Try this again. So I create a view. May have to. I need to be patient. Okay. Let's take a deep breath and enjoy the loading. It's like computers used to be. Forgot about that. Web pages that take 3 minutes to load. Okay. Now we're being patient. Although this isn't the data warehouse I was looking at before. That's the one that we loaded on. That's the one we loaded in the last class. The overall fact table. So should we refresh that? Oh, where'd my... Maybe I chose the wrong data warehouse. Let's go back. I was in the right data warehouse, and then it's like, as in a different one. Okay, so warehouse. Oh, there's our crypto again. It must have took me to a different warehouse. I create this view. Just right click it. It's like the IDEs that we have. It's like the IDEs that you use in the SQL class that I teach, the MySQL Workbench, or if you use Microsoft products, SSRS. Then I forgot what the other ones were. I used DB2 a long time ago. Okay, views, fat coin history. Let's try this again. So this is a view that I create. Usually it's more complicated than this. I'm just bringing together, or I'm just cleaning up this column and then including all the other columns. Pretty simple what I'm doing with this view. Other times I would, like I said, I'd bring together multiple tables. Even in Fabric now, you can query Delta tables in Delta Lake. It's possible that you could do that to bring together different sources for whatever you need to be able to create a machine learning model. So if I just run this, let's just run fat coin history. So if we just select star, from our view, so now we have this crypto date time that we can use. We needed this for the model.
Could you pull up that transformation you did again really quick on the on that date?
Oh yeah, the fat coin history into the view.
Yeah.
Yep. So this one's a simple one. It's useful to have. I looked this one up because there's always little tricks that I forget, even using databases for a long time. But this is like converting it to milliseconds. And then you have that history.date. That's like that 13 length number, 13-digit number, Unix. And it starts from 1970, 1970, whatever. For whatever reason, that's when Unix system time starts. It's probably about when Unix was invented. Maybe just slightly before. But yeah, it's since that date. I looked that one up. And then it takes that time, then creates this SQL Server date time out of it. So it's in this format: year, month, day, time, which is hours, minutes, seconds. And that's when this observation was recorded. Each one of these. Probably Central Meridian time or something. That's a thing. It's like that time prime meridian time. All right. Okay, so I did that. I went into AutoML, and then it looks for tables inside of a data lake. So for whatever reason, I couldn't just query it directly with AutoML. So I did one more pipeline. And there's probably I'm certain that there's a more elegant way of doing it than I did here. So what I did was I did one more pipeline that takes my view from the data warehouse and it puts it in a table in the Delta Lake. Because for some reason it seems like AutoML is always looking for tables in the data lake to run the machine learning models. I'm kind of surprised that you wouldn't be able to run it out somewhere else, and you probably can out of the notebooks if you did it in the notebooks. But I ended up doing this also. So I go from warehouse, ODSA test, the table, I'd say schema, and then the view. So not technically a table, but you can still run it like a table, a view like a table, because it's just a piece of code that creates tabular data set. Then the destination, I selected the lake house, and then I did tables, and then I gave it a name. So I gave it a name ML to say it's going to be for machine learning, and then coin overall history. So I just gave it a descriptive name of what it is. So coin could even be fact over fact history. So you can preview the data. You wouldn't have any there the first time because the first time it creates a table. If you run the pipeline, and go back to the data lake. This is the warehouse. Oh, data lake. This is what the table in top 10 looks like. So we'll go back to your lake house, data lake. It creates this table here off of the view. And then there are the results with that date time that I cleaned up. And then these other columns also. So now I think the theory is that a lot of machine learning models are created out of data sources in the data lake. Although they can be created from anywhere, it kind of makes sense because oftentimes this is like real-time data or huge volumes of data, and you end up managing a lot of it out of the data lake or Spark or some other type of real-time processing. So I did that, and now the setup is here for a machine learning model. So we'll go ahead and just repeat the process. So what I did is went home and then to data science. And then you have these options. You can go straight to creating a notebook. You can create a machine learning model or run an experiment where you're running multiple models and validating hypothesis. What we want to do is do AutoML. So you can go into your workspace. You can see I've already created a couple here, but we'll create a new one. All right. So we have what did I do here? All items. You can create a deployment pipeline up there. Okay. Notebooks, data pipeline. It's not there. Let me go back. Data science. New workspace. I did click machine learning model. Create ML model name. I created this name already. Machine learning model, first and last name, coin history. Instead of calling this model, we'll do ODSA. Okay, that was it. So I was looking for AutoML over there, but you just need to first create a model. Go to the create a model option when you're in data science. So you can do it a number of ways. You can start with an experiment, a new notebook. You can start with one of your existing notebooks or start with a template. The template's not bad, but we're going to go AutoML because this will also generate a template for you. It'll walk you through steps and generate a template for you. Okay. So we want to choose the data source. It's looking in the One Lake Data Hub. Okay. So we have the ODSA Lakehouse. Can choose data. We have that table we created from the view, the ML coin overall history. We had with that converted date time. Okay. So you can select the type of model. So we're getting into cleaning up the data, and then it will choose a number of models for you. So the problem with the data set that I have now that we can't do forecasting is because we have dates and times that are unequally spread out. If you did each one of these by date, it'd probably be okay. But each one of these are like hours apart. So if you wanted to do forecasting, like get one per day or make sure all of the observations are evenly spaced by time, we'll just go with regression here. Regression is just predicting market cap based on some of your existing numbers. Okay. So AutoML mode, choose one that best matches your goal. You can do a quick prototype, interpretable, best fit, or custom. You can see some of these will take more than others to do. Best fit, it'll go through a huge number of models. Our data set's small. We can do a quick prototype on it. Okay. Choose a prediction column. We'll go ahead and predict the price. Okay, and you can do some other things. You can manage the different types of columns, and if they're missing values, what do you do with them? So, and you could tell it to create features like we talked about, some of those predictive values. Okay. So final details. So you see we have two options. We can use Pandas Dane frame and train multiple models, or we can train one model at a time using Spark to distribute the training. This one will use scikit-learn. This other one will use Spark ML. We'll just go ahead and use pandas, and we'll go ahead and use pandas and scikit-learn. Name, notebook experiment, AutoML notebook. Let's see. ETH, price, prediction. Just give it something descriptive. An experiment always goes along with it. So this will be the name of the experiment. And here's a machine learning model name, the same as what we gave it at the beginning. Okay. So view and create notebook. You can even preview the code of what it's going to look like. Go ahead and create. Okay. So it creates this notebook for you. That's PySpark notebook. It does a pretty nice job. See, loading the data, creating features, train an AutoML trial, save the machine learning model, and predicting with the saved model. So it creates this code for you. So it's not, we'll find that it's not always perfect. But it comes up with all these different settings that you can adjust. So until you get familiar with really like writing this type of code or have a few notebooks, this is a pretty good way to go. And then you can do predictions with the saved model, display those, and then save the results to a delta table, predicted values to delta table. So we'll go ahead and run this. It actually creates a Spark instance for you once you get it up and running. We aren't using Spark ML, we're just using scikit-learn, but he'll create a Spark instance for us to run this Python code on. And you see he'll install scikit-learn. All of that's okay. Just some warnings. Is already installed. So it's running, you can see it's running through each one of these steps. You can display, it'll display your data set. It's a pretty good workflow for, this is what something a data scientist would create. Featureization, creating those features. A converting object to the nearest types. So this is doing your train and test, splitting it up into that. So logging the experiment in ML flow. All it's saying is that it doesn't exist, so we'll create a new one. This is how you can manage your different versions of the model. You configure the AutoML trial and settings. And then we have our first error here, of course. Let's see. Server failed to authenticate the request. Let's go ahead and try to run this another time. You can just rerun a cell. See if we get the same error. Ran successfully that time. Okay. Once in a while, I noticed as I was running this through these is that it almost goes too fast. And sometimes it creates an error because of that. But you can rerun each part of this. Run the auto ML trial. Oops. Oh, that produced an error. Let's see. Long error. Cannot cast date time array. So you notice when it generates, basically when it generates code, it's not always perfect. May have to go fix it up. Let's just put that in Claude. Or actually Chat GPT. Sometimes I'll give a better, instead of trying to produce a bunch of code. So what I want to try to do by the end of this demo is get this deployed and then send a request to the REST API. Okay. Oops. Browser's working slowly. Deployment on the Windows updates. Oop. Okay. Perform an operation that expects numeric data on date time events. Best approach depends on your use case.
I think I found where it's bombing, but I'm not positive. There's a place where we call. Hold on, I lost it.
Let's see.
Too far.
Do it.
We call this x dot convert d types, and I think that's it.
Where's that at, Skylar? Down here with the error?
It's in featureization, step 2. Down a little from there.
Or do featureization.
When we call, it's just below this one. We call in the next cell x convert to d types. Up a little bit. One cell right there. Nope, that one.
Well, yeah, convert object.
I think if we like above that, like tell it explicitly to convert the date column to date time, I think it'll work. I don't remember the name of that column. I clicked their date time.
Like D types. There's this one down here, fill NA based on D types. I kind of know what it's doing. It's trying to change that into a number and use it for prediction. Date time, select D types. We want to convert that specific column to it. Let's see. I always look these things up. Guess maybe I should have left it. Can use pandas to date time. It's an example here. Extracting date components. So we want to do something like that. PD. You know what? We're kind of running out of time, so let's see if we can use an existing example here. Notebook of a model. Let's see. Let's go to data science. Explore a sample. Maybe I should just done that in the first place. I didn't even get that same problem when I was working on it earlier. Had a different one. Let's just do time series forecast. Similar to what we're trying to do with the crypto prices. Okay, so this is an end-to-end data science workflow for time series forecasting, which is great. It uses this package called Profit, so you can use almost anything library that Python has. Okay. Just says you can install it a couple different ways. It uses Anaconda. Downloads. There's some publicly available data in this Windows blob. It shows how long it goes. He had some time to show how long it goes. Okay. Set experiment name. Can display the results. So similar to what we were doing. You can aggregate the data. You can do it here instead of doing it in a view, which is just fine. You could just choose to do everything in a Python notebook instead of doing it in different steps in Fabric also. Okay, aggregate the sales price, converts PySpark data frame, or from PySpark to pandas. You visualize, train the model, log the model with MLflow. You conduct experiments, so machine learning experiment corresponds to single execution of model code. Machine learning experiment tracking refers to management of all the different experiments and their components. So it includes parameters, metrics, models, and other artifacts. So it just helps you track what you changed in the results. Okay, you can do a bunch of visualization, score the model, and say prediction results. Okay, let's run this and then try to deploy it. If it runs successfully, it should show up in our workspace. We can deploy it. Not happy with that. I think it should still be running. Okay. Let's try to run this again. And let's see if I can't. I'm going to export this so everybody has a Python notebook so that you could import it or upload it to your workspace and run it also. Put that in Slack while this runs. Seems like it's running. Let's make sure. Maybe not. Okay, starting up the Spark instance. Okay, starting the session. Okay, now it's running through everything. You can tell by the spinning cell. Okay, while that runs.
I think I got the other one to run. Didn't bomb out yet. Else.
Did you?
Yeah.
You want to? This one will be done here in a second too.
Say again. Sorry.
Oh yeah, it's cutting out just a little bit. Yeah, I think I'm running. Well, this code ran into an error. So, Skylar, let's go ahead and see yours.
All right. We'll see if it's
If you're able to
rolling.
see it. Appreciate the wizardry.
Absolutely. I'll just do entire screen. Screen 2. There we go.
I'll have to change the lake house and stuff like that in this one. In that other example that I was running, you have to change like lake house location and stuff for like that. File path names.
Oh, you may need to allow my screen to be
Okay.
in the show as well.
Let's see. Yep. There we go. Okay, go ahead, Scott.
I did do it. Okay. So the one it was this function was being mad. I think I saw it pop up on your chat GPT for a second. So I was like, oh sure, why not do that? So I converted the crypto date time, broke it out into year, month, day,
Oh, nice.
and then dropped crypto date time since it was giving us pain. And then when I kept running through everything, this is the one that was bombing. It's still running because it looks like we have multiple going, but it's finishing actually now instead of saying failed. So still rolling, but
okay.
That was the
Let's
main
just
thing.
hang in there with this because once it's done, it should show up in our workspace, and then we can deploy it. So how you can?
Children.
Yeah, it's not on that many observations either. It's trying different models.
Strange. So it's fitting. Is this the? Oh, it is. Splits 3. They've been seed 41. They think they're funny. 42 is like the typical seed people use. Hey, okay, we finished. Then should I keep rolling? Wait, no. Yes. Yeah. Okay. Then I need to run this one. Yay! Create a new version of this model. Dun, 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 dun. Okay. And then I'm predicting. Should I run this one or?
Yep. Go ahead.
I know this isn't hitting the REST API or anything, but
I think at the end it will show the predictions.
no. History cap it could be history cap or history cap.
Yeah, that's the problem that I had earlier is that there are two columns that are
Gasp.
nearly the same.
No. That's so close.
I tried dropping it out of
Okay.
the data frame too, but it wasn't dropping out of it.
History cap is ambiguous. Okay, sure.
You could just drop both of them.
Yeah, that's true. Since we're not like. I gotta do a back here. I'll just drop it here too. Drop columns. You. History cap and history cap. Right? Yeah. Okay. Is it gonna get mad if I try to run this again? Yes. Yeah, because I already dropped that. Let me back up. Run this one. Re-imported. Okay. Redisplay it. It is there again. All is right with the world. I didn't really need to run that function one again. That's fine. This. What's the function they did out there? Okay, so then I'll do display X again. Okay, they're gone. Yay! Exciting. I run you. I don't think I actually need to do that one again. But that's okay. 1 second. I don't think I need to do this one, or we're just gonna run it all anyway.
Yep.
And you run. Okay. There we go. This one will take a minute or two. It's doesn't like capitalization down here, huh? Technically, they're different.
I know. Or it could rename it for you.
That's true. Yeah, that's what it kind of looks like it's doing, right? It's because one. Well, yeah. Oh, here, sorry. I'm just like scrolling like a madman now. Oh, this is the last run. I was tricked. I should have looked at how long the last one took to run. Oh, this is the new run. Okay. The last one came back with 4. Ooh. Don't click that now, but
Skylar, I thought of another reason why you would deploy a REST API. So it doesn't necessarily have to be real time, but say it was like someone calling into a call center and you wanted to calculate a risk score. If you wanted to do a prediction in real time,
Mm.
you could send that information and then do a real-time prediction and then just have that reappear. That could be useful.
I have one where we provide a software. We have people who have ideas out there. I don't know that this probably doesn't really need to be. Well, no, it kind of does need to be real time ish. Where they vote on ideas for the software, so they create and vote on ideas. And I already have the model set up to where it'll say take their like last three, choose one at random, and find one that's similar to it based on words, essentially based on vectorization, and then provide three back. So we need our front end person to call this. I need to set up an API so a front end person can call the API so that while they're browsing it, right, it can pop up and be like,
Yeah.
you liked this, so here's the other three things.
Yeah, if you're making something that's almost like real-time prediction and predictable inputs, might be one of the best ways to package up a model and let you do it, have you do it.
Not the last one did not go 6 deep, but this one's really still chugging.
Yeah, it's definitely where on a huge data set you'd want to use Spark. Said you like infinity time, or wouldn't even be able to do it. But once you have the model built, it's all about Spark versus scikit-learn would be all about model building. Once you have it built, it's not that big a deal. Still running?
Still going.
Oh, man.
The last time, I don't know why dropping those two columns made it want to go longer, but
You can make quite a bit having some of those predictor variables. Dropping it can change the model quite a bit.
Haha, this is looking okay. Haha, done. Now I can do this. This one's snappy. All right, moment of truth. Well, it didn't yell at me, so that's good news. This comes back with 100% accuracy. I gotta go buy some Ethereum right now.
Oh, I bet it might, because there's volume in there.
Oh. Okay, so it's saying it's just giving me some inputs with a history rate. Get the predictions to a table.
Yeah, so I'll write it back to Delta Lake table. The predictions.
Should I go and do that? Yeah, ML. Why not?
Yeah. So you could view those in Power BI then.
And that was doesn't really okay, Delta, so that'd probably be in the Lake House, right?
Yeah, that's what I meant to say. Should be a table in the Delta Lake House.
Ha ha ha. There it is. All right, I don't need all the records. Just give me the top 100.
It only has like 100 records in it. When you put together final project, might not take a whole bunch.
Oh yeah, there's only 21 records.
Does it have a
Bit
prediction in there? I can't see.
I can't tell what the prediction column is. It must be. I assume it's
That
this.
last one? Yeah. So now, if you go to your workspace, Skylar, there should be a model object.
Here it is.
If you click on that, he'll give you some. Oh,
Oh, interesting. We already did start with MLL on this one.
if you go back, let me see. You should be able to click on that and like see the fit statistics, maybe the dots that are next to it.
Yeah, hold on. Let me like refresh just for fun. Oh, here's the. This is the experiment. This is the one we just did.
Oh yeah, open experiment. Yeah, the experiment. They're your fit statistics.
Oh, nice. Yeah, look at
Almost perfect.
that.
Probably a little high. What I try to do for this project is I'll put it together tomorrow, but try to do a forecast. Just get one observation per day and predict it that way. So you should be able to now deploy this if you go back.
Back to like the workspace.
If you and select the model, and there should be an option to deploy.
Apply.
Yeah, you might have to apply one of the versions first. I try to.
All right.
It
That's
says
the
select model and model registry, and then click the deploy button.
model registry. Where is the model? View ML model list.
That looks like that might be right. Because it is like this way in the Azure machine learning library.
Look at that. Look at that drop. It started 0. That's not. Okay. Sorry, I got sidetracked.
On version 2, if you click those.
Oops, sorry. There you go. Ah.
Were you able to apply that version or click those dots?
Let's do this. I can open it. I mean, I can apply modeling wizard. I can do that. With the input, name output, name notebook. I mean, I think we already did that technically.
Yeah.
Like it wants me to reapply it to some other. Like this is the model wants me to apply it to other data. Is kind of what.
Oh, you know what? You might have to do that. Actually.
Because it thinks because we just trained it. Now it wants us to like do it on quote unquote production data.
Yeah.
Sure, I can do that. Yeah, this one, it doesn't need to know. History date, history volume. Why did you should know? Year. Oh, I don't have a year, month,
no.
day. Now convert. Well, you should do those transformations for me. I put them in the code. Ah, shoot. No.
I'll tell you one thing that platforms like Dataiku or Databricks make this a lot easier.
No, they have their nice little pipeline. We have Dataiku.
Yeah.
They have the nice little data transformation.
Do you?
Like step,
Yeah.
and then I've not yet been able to deploy a model yet. I think that's a configuration issue. My fault. Okay. Maybe I can take this off too, and I can make within here.
Yeah, once
Well,
we get a successful model, I'm working on it tomorrow. If I get one, I'll record a video deploying it.
sweet.
Appreciate wizardry here, Skylar.
Of course. It was really just your chat GPT that I stole the idea from.
Like I was saying, it's good to have two eyes on it sometimes. See it just another way. I'll let everyone go for the final lecture. We will do a short one on the real-time intelligence. In the meantime, I'll do a little video on deploying. Once I get a model built, I'll help a little bit. I'll give some hints about the data too, on what to use. I'd rather do a forecast so that you're forecasting the data. I'll give some instruction on that and create a model and how to deploy it for the class project. Right. That's it for tonight. I think everyone's had enough. Appreciate your help here, Skylar.
Absolutely. Have a great night.
Right. See everyone for one more class on Wednesday. I'll be there live, so if anyone wants to sit and work, we'll work through class project, and I'll just keep the video on too for anyone who has questions remotely. Then we'll assign the final exam too. Right. You'll hear from me tomorrow, and see you guys. See you guys Wednesday.
All right. See you Wednesday.
Bye. All right. We'll finish up the lecture. All right. So that is it for Class 6 Omaha Data Science Academy, where we learned about machine learning and artificial intelligence services, and we worked within microfabric data science to create models using AutoML, and we're working on deploying, model building and deploying and maintaining those models. And then in the final lecture that we have on Wednesday, we will do a short lecture on real-time intelligence, and then we will work on the final project, which is the end-to-end data science platform. So this is Jeremy Bergman, instructor for Omaha Data Science Academy, and we'll see you next time. Thanks.